Question 3 is all about trigonometry, and it's a fairly tough question which dives in at the very beginning with a question on the cosine rule. So if you look at the triangle, you've got information on two sides and the included angle. So whenever you see side angle side, you should be expecting either the cosine rule like we've got here, or the question that you should anticipate is how to find the area of a triangle using the sine rule, where you could use the rule half AB sine C. Anyway, this marks a triangular boat race course, and the race starts and finishes at point A, so they go all the way out of the triangle, and we're asked to find the total length. So we've got AB, which is 700, and BC, which is 900. So we need to work out this length here, AC. So we can use the cosine rule, so we know that AC squared is going to be BC squared, so 900 squared, plus AB squared, which is 700 squared, minus 2 times 900 times 700 times the cosine of the angle between them, so cos 110. So that's just the standard formula for the cosine rule. A squared equals B squared plus C squared minus 2BC cos A, where B and C are the two parallel sides, and large A is the angle in between them. So if we work that out, we end up with a value of AC squared, which is 1,315.65 meters. So if we add that up with the other two lengths, the total length of the circuit is going to be 2,915.65, which we can say is 2,920 meters to 3 sig fig. And in part B, then we're told that an estimate for the fastest boat in the race is one that travels at speeds of around 1.5 meters per second. So just note the units there. Calculate an estimate of the winning time for the race. So for part B then, we know that speed equals distance over time. So time is going to equal the total distance over the speed. So the distance we've got in meters, which is we're going to use this value because it's more accurate. So we're going to use 2,915.65 divided by the speed, which is 1.5, which is going to give us an answer of 1,943.76. That, however, if we've got meters and we divide it by meters per second, that's going to give us the time in seconds. The question asks us to give it to the nearest minute. So we need to take our answer, so 1,943.76 divided by 60 to get the number of minutes, which is going to give you a final answer for part B of 32 minutes. Part C asks us to find angle ACB, which is going to be marked on the triangle here. Now, there's a couple of ways you can do this. The easiest way is to recognise that for this angle here, you have got the side opposite. And similarly, if we look at B, we've got this angle here and the side opposite. So we've got two pairs, so an angle and a side, and there's only one piece of information missing. So what we should recognise from that is that we can use the sine rule. So if we want to find the angle, we can put the angle on top. So sine theta, which is going to be this angle here, divided by the length of the side opposite, 700. So the ratio is going to be the same as the sine of this angle, sine 110, divided by the length opposite, which is going to be 1,315.65. So we're just going to take this and multiply it by 700, which is going to give us 0.49997, and that's going to be sine theta. So if we want to find theta, we need to do inverse sine of 0.49997, and that is going to give you an answer of 30 degrees. At the beginning of the question, I mentioned that if you look at a question and you are provided with information on the side, the angle, and the side, there are two types of questions we can expect. One is going to ask you to find this length AC, for which you can use cosine rule. And the other one we mentioned was how to find the area of a triangle using the sine rule. And no surprises, part D here asks us to find the area of this triangle. So the formula for the area of a triangle using trig is half AB sine C, where A and B are the two lengths either side of the angle in the middle C. So here that's going to be half times 700 times 900 times sine 110, which is going to give us an answer of 296,003 meters squared. Next, we're asked and giving a reason here, whether or not the course complies with the safety regulations. So the safety regulations up here tell us that the area inside has to be kept clear, so we've worked that out, and the shortest distance from B to AC must be greater than 375. So the shortest distance from B to AC is going to be a line which is perpendicular to AC. So if it's perpendicular, we know that that's going to be a right angle. So in effect, we can look at this triangle here. We know the hypotenuse is 900. We want to work out this length L. And from the previous question, we know that this angle here is 30. So relative to this angle here, this is the opposite. And we've got the hypotenuse. So I hope you can realise we're going to be using sine. So sine 30 equals the length opposite over the hypotenuse, which is 900. So the length is going to equal 900 times sine 30. And if we do that, you end up with a length of 400 meters, which is greater than 375. Therefore, it does comply with the safety regulations. This question doesn't seem to keep on going for a very long time, but we are in the final stretch now. And in question F, we are given a question which involves a helicopter. We are told that the race is filmed from a helicopter H, which is flying vertically above point A, and the angle of elevation of the helicopter from point B is 15 degrees. So if you imagine we are at point A, the helicopter is flying up here somewhere, so that's the helicopter, and we're told that the angle of elevation from B, so B is going to be over here, and the angle of elevation from B is 15 degrees, and we're asked to find the height AH. Now we know the distance on the ground between these 2 points is 700, so if we want to find AH, then relative to the angle of 15 degrees, we have got the opposite and the adjacent. So therefore, we're going to be using tan. So tan 15 degrees is going to equal the opposite, which is AH over the adjacent, which is 700. So therefore, AH is going to be 700 times tan 15, which is going to give us an answer of 187.564 or 188 meters to 3 sig fig. Finally then, calculate the maximum possible distance from the helicopter to a boat on the course. So if our helicopter is above point A, you can see hopefully that the furthest boat, or this distance, will be as far away as you could get on the ground. So if you look at the ground, we've got A here, and the furthest position that the boat can be is at C, and we know from a question A that that distance is going to be 1,315.65. Now we've just worked out that a helicopter up here at H is going to be at a height of 187.564. So that's the height here. So we've got a right angle triangle. Therefore, the maximum distance that the helicopter can be from the boat is going to be the hypotenuse here. So if we've got the two sides, we've got 1,315, and we've got this side here, which is 187.564, we are just going to use Pythagoras to solve that. We should end up, therefore, with a final answer for HC. So we know that HC squared is going to equal 1,315.65 squared plus 187.564 squared. So if we take the square root of the solution to that, we end up with a final answer for HC, the maximum distance between the helicopter and a boat of 1,330 meters.